What's up guys, this is Tank Control Games bringing you another Unreal Engine 5 tutorial, and today we're going to be creating a system to detect the surface type underneath the player. This will allow us to do different movement modes depending on if it's like snow or grass or mud, and then we can actually affect the character movement component and then make it feel like you're actually walking on those surfaces. This tutorial is going to be pretty simple, but it'll set up a foundation for a bunch of future tutorials I want to do. I want to really get into stuff like render targets so we can scratch the surface of these materials like if it's ice, or do something like snow that you can actually walk through and melt under your feet. So we're going to be doing that a little later on, but this will be the first step. So if that sounds interesting to you, let's get started. Okay, so for this tutorial, I'm going to be using Unreal 5.6. So let's launch the project browser. So once that loads, let's go to the Games tab and then find the third-person template. We're going to use this as the base for the system. So let's just name our project Surface Detection, and then do Create. So once your project loads, click play, and you'll see our third-person character. We can move around, jump. We're going to use this as the foundation for this setup. We're going to be modifying the values of our character movement component to simulate ice and different ground types and surfaces. So to set that up, let's first add a few different surfaces to the project. So if we go to Edit, Project Settings, and then just search Surface. And if you scroll down to Engine Physics, you'll see Physical Surface. And we're just going to add a couple here. So let's do ice and snow. And that's probably all we'll do now. We'll just do ice and snow. We could do grass and stuff as well, maybe just so that we can see all of them switching. So let's also add grass. So we have ice, snow, grass, and default. And I think that'll be good enough for now to test. So with our surfaces, now what we want is some physical materials, so that we can apply them to actual surface objects in the game and then be able to detect those. So what we're going to do is do a new folder in our content drawer. So do new folder, physical material. And then in that folder, let's right click and let's add a physical material. So find physical material, and then let's do, you just have to click the class when it says pick physical material object class. Let's name this PM. Let's start with ice, so we'll say ice. Then let's add an ice object to our scenes. So search for cube, and then this will be our ice. So we're just going to scale this out to a surface just large enough so that we can actually test moving around on it. So maybe something like that. Over here. And let's just, because we're going to do our different surface types, let's just duplicate that. So Control V with it selected and then drag out. And we'll do that again just for a third one. So we have three different surface materials now. And then to distinguish between these two, let's also just change the color. So let's make this one blue. And it's close enough to ice. And then this could be our snow. And this could be grass. Let's just make this green. And then this default one, all of our other surfaces, we'll just make this the default. And without changing anything, it actually will be the default. So that should work perfect. So we have 4 different surface types, but obviously we haven't changed anything. So walking on these now, it'll just be like normal. So let's add our physics material to the ice. So with this cube selected, search override. And you'll see phys material override, and we're going to make this PM ice. And then one other thing we have to do, which I forgot in our PM ice, we also want to set this physical material to be the proper surface type. So if we look under physical properties, we see surface type, and we'll just set this to be ice. So click save. And then let's make one for snow. So just do duplicate PM snow. And then duplicate and do PM grass. And then in each of these, let's just make sure our surface type is the proper one for the material. Do that for snow as well. And then let's set the override on each of these objects as well. So this will be snow, and this will be grass. Cool. So if we click play, nothing's going to happen. We have to first be able to detect the material under the character. So to do that, let's open up our third-person character. Okay, so in our third-person character, the first thing we want to do is click on the capsule component and search for return. And you'll see return material on move, and if you hover over it, it says if true, component sweeps will return the material in their hit result. And we want to use that, so we're going to click that to be true. And then to actually utilize that, it's you'll see that little like @C movement component. Even though this is a setting you set on the capsule component, to actually see those hit results, you need to do your character movement component. So we're going to make a function that actually checks what's under the player. So to do that, let's do plus under functions, and then name it something like detect surface below player. And then for this, we're going to drag out our movement component, and then we're going to do, I believe it's current floor. Yeah, just like that. And let's split that struct. And you'll see we get a few different things that we can use here. So we have current floor blocking hit, current floor walkable floor, current floor line trace, all of these different options. The first one we're going to use is the current floor blocking hit. And basically we don't want to progress with this function unless you are currently hitting some type of surface. So we'll do that check just kind of as a safety check, so we don't do any of the following stuff beyond that. And then what we want to do is split our current floor hit result. And then the one we're most concerned with is surface type, which you don't actually get an option for that here, as you can see, but you can get it off of the current floor hit result physic material. So if you drag that out and then search surface type, you'll see get surface type. And if you hover over this, this is of type E physical surface. So it's an enum, and this particular surface type is the one we want to use. And this is actually corresponding with the surface types that we have in our project setting. So if you want to see that, just as a quick test, if you did like switch on E physical surface, you'll see there's all of the surface types we added to our project settings. And we're actually going to utilize this a little bit later on. So for that though, what we really want to do is check whether the current hitting surface is the old surface. So let's add a variable, and we're going to call this one this is going to be of type E physical surface, just like our other surface types. And we're just going to call this old surface. And we'll set that in a second, but basically we want to see if the current hit is the old surface. So drag off surface type and search not equal. And then it's really important, you don't want to use the operator version, you want to use the enum version, because the enum version will have all of our different options. So hook old surface up to that. And then we'll do that check. But before we do that, just to show that this works, let's just do a print string. And let's hook our surface type up to it, just so you guys can see what this actually does. So all of that looks good. And then to actually utilize this, let's do this on tick, so we're just checking every frame. So drag out your detect surface below the player, hook it up to the tick function. And then right now all this is going to do is make sure you have a blocking hit so you're not in the air. And then if you do, check what the surface type is and print it out. So when we click play, yeah, you'll see it's going to be default on any of these objects because we didn't change any of the physical materials on there. But if we go onto our ice, it says ice. Onto snow, it says snow. And go onto grass, it says grass. So the detection's working. Now let's keep building our function. So remove that test. And then we have our check here, which is what we want because we don't want to do all the code after this unless the surface has changed. So we hook that up to true, and then what we can do right when that when those aren't equal is we can set the old surface to be the new surface. And we can just drag off here. Let's add some reroute nodes just to keep this clean. And after that, we want an event that can tell us when the surface has changed. So let's actually create that. If we go back into our main graph, let's do custom event. And call this on surface change. And let's have this take an input, and the input will just be the current surface. So go into your details panel, click the plus under inputs, and then let's just do current surface. And then again of type ePhysical surface. And then in this function, let's actually call that. So let's look up surface on surface change. Yep, just like that. And then the current surface is just going to be the surface that we're hitting at the moment. So let's drag this down like that. We'll add another reroute node. Okay, so basically what this is going to do, it's going to check the current surface that we're hitting, check whether it's not equal to the old surface, and if it isn't, it's going to set the old surface to be the new surface, and then set on surface change so we can trigger some logic that happens only once, because once you set your old surface to be the new surface, then it'll just stay in the false path until that changes, which is what we want. We don't want to like constantly be running the logic that we're going to do off of on surface change. We only want to call it when the surface really does change. And then to test this out, let's just do a print string again. So whenever the surface changes, actually maybe more than a print string, let's actually just see what the current surface is, but this should only print once because this only happens whenever the surface changes the first time. So let's see if we're still seeing our detection working. And we're probably not going to see anything change until we actually cross over a different surface other than default, because our previous surface and current surface variables are all the default initially. So if we cross over, yep, now we see ice, snow, and grass. Yep, it's all working perfectly. Okay, cool. So if we go back to our event, let's just remove our test code. And what we want to do here is let's just set our current surface to be a variable. It'll just make using this a little cleaner. And then off of this, we'll do a sequence, and there's kind of two paths we're going to take. First, we want to set basically all of the values that we want under character movement to change the movement behavior on different surfaces off the first sequence. And then on the second output, we're going to have an option to do further logic if there's anything like specific for these surface types that we want to trigger, like only one frame and basically after this event gets called. So to just set that up just for future use, let's drag off and do a switch on ePhysical surface as all of our different types. And we'll just hook that up like that. The other great thing with this kind of setup is like as you expand your system and you're adding different surface types, it's really easy to just change the behavior per surface. And as you add something new under your project settings, if you were to add like another surface type, all you have to do is click like refresh on these nodes or refresh the whole blueprint, and it'll keep updating this, and you can add or subtract any of these different surfaces as you want. So we'll do that, and then what we can do as a quick test is like, let's just do something just so you can really see. Let's set walk speed. Let's set the max walk speed to be like something insane when you're on ice, just as a really easy visual so you can see it working. So when we switch on ePhysical surface, let's just do like max walk speed becomes like 8,000 or something. That's gonna be crazy, but let's see. Because it's, I believe, default right now under your character movement component. he has like 600, so this is going to be really fast. But right now they're walking normally, and then if we go onto the ice, now they're like flying fast. So, and they're still fast, you noticed when they switched off the ice, and that is because we're not actually going back to our default when we're not on the ice, and I'll show you how we're actually going to handle that in a second. So at least we know that that's working, so we're not going to do that. And we want a clean way to be able to set these different movement settings kind of all at once and without having to like rehook things up in a million different ways. So a clean way to do this is to use one function. So we're going to create a function that is just used to set character movement settings. And then this is going to take in some inputs. So we'll just have it take in all of the character movement values that we want to change. So the ones that we want are ground friction. This will be a float. Braking, deceleration, walking. Braking friction factor. Max walk speed. And max acceleration. So there is more settings under the movement component, and you can actually add as many of these as you want if you really want to like change these different behaviors. You could get like pretty crazy with this. You could even have it like go zero gravity if you wanted when they cross over certain things. But for now, we're just gonna use this because we're really focusing more on like the ice and the snow. These should be good for now. So what we want to do is set these values in this function. So let's add a sequence. So you can either click in the graph and press S, or just search sequence. And with that node, let's add one for each of these. And then we're going to set each of these variables off this. So do set ground friction. And you can drag off the pin from the function and go straight into the set node. But that can get kind of unruly when you have a bunch of different inputs that you're setting. So something that is a little cleaner, if you search ground friction, you'll see this get ground friction variable. And this is actually the functions version of this. So like you could have outside variables too that it might find, you know, something called the same thing. But you can get the specific one that's the input from the function, and you know that by this little f on the variable itself. And you can just hook that up like that. We can do that for each of these, and it just keeps things cleaner. Cool, so this is our function done. We're setting all of these values. And then if we go back out into our main graph and we drag this function, you'll see it has all these pins. So you can drag this out and you can manually set this. And you could, in theory, you know, have a different one of these for each version of your surface and then set different values. That's one way to do it, and that works perfectly fine. An easier and more expandable way so that you don't have to keep doing that as you add more surfaces is we're going to bring that out, and we're only going to do this once. So let's make a struct actually. So if we go back to our content drawer, make a new folder, structs, and then search for struct. And a structure is just like a container for variables, basically. So we can do s underscore, sorry, not structure, s underscore movement values. And then this is kind of going to be a parent for this variable that we'll use in the blueprint. So let's open this up. And then it starts with a Boolean. We're not going to actually use a Boolean. We're going to use all floats. And then we just want one for each of these settings. So ground friction, braking, deceleration, walking, braking friction factor, max walk speed, and max acceleration. So I'm going to add those right now. Cool, so I think that's all of them. And then we can set default values on each of these. And let's actually just make it default to what our character movement component initially uses. So let's search each of these. Ground friction is 8. You can just copy that. Paste that there. And then let's see, braking, deceleration, walking is usually 2000, so we'll also set that. And then friction factor is 1, so we'll do that. Max walk speed, I think we said was 600. Yep, so 600. And then let's see what acceleration usually is. 1,500, okay. So that should be good. So it's defaulting to the default values that we use in our movement components. Let's save that. And then in the third person character, let's add another variable. And this is going to be of the type of the struct we just created. So s underscore movement values. And then this will be default movement values. So this is just the initial ones that we get from the character. Let's drag this in. And then to make use of this, let's also get our current surface that we're setting. And then instead of switching, let's do a select node. And then this is the cool part. This is where it's going to be super expandable and really easy to add to this. So we have this select node, which when you use your enum, it'll show each of the different types. And then you can just hook up our struct, and then now all of these variables are expecting that type, and we can keep just duplicating this and making various types and different settings for each version of our surface. And then you can't hook this up directly like this, so you do have to split the struct. And then you'll have all of these float values, which you can just plug in like this. And now you don't have to hook this up every single time and have like a bunch of different functions that are doing this. It's just all going to be this one function. But we do need something to put in each of these. If you have them blank, it's going to default to this one. So you just want to fill that out with different S movement value structs. So let's create one for ice movement values. Duplicate, and we'll do snow movement values. And duplicate again and do grass movement values. And let's hook each of these up. And obviously right now they all have the same values, so let's actually change them. So let's set ice to feel more like ice. So compile, and then you'll be able to see your default values. So for ice, let's do like really like no ground friction at all. So it's super slidey. So it's 0.05. And then for braking, deceleration, walking, let's do something like 50. So it's way less. And then braking friction factor, we'll do like 0.02. Max walk speed, let's make them go faster on ice, but not like, not a ton faster, maybe just like 800. And then for max acceleration, let's also just lower that so it takes longer to accelerate. And then this will also just help them feel like when they're turning on the ice, it takes longer to actually turn around. So that should be good. So we have ice. For snow, probably don't have to change a ton. I think we just want to go slower when we're in the snow. So let's set this to something like ground friction 300, so there is a little more friction. 2000, we probably just keep default. And then let's make them go slower. So let's say the max walk speed is like 200. And then grass, probably not gonna have like a big difference between grass and snow. Honestly, you probably wouldn't walk as slow in grass. Grass might just be pretty much like default. Maybe we can walk like slightly slower. We'll just say like 500 max walk speed, so it's just like a little less. And then maybe we can bump up the friction to like 40 or 50 maybe. We'll try that and see if it feels any different, but this is more of a test anyways. You can really tweak these values and change them however you want. Okay, so let's hook that up. And then let's test this out. So do compile and save. And then let's click play. Okay, so we're walking around now. We're at our default walk speeds. Everything's still working. And then let's go on the ice. Oh yeah, and it's working now. You can see you slide around when you start to move forward, and then turning is not like as controlled as before. It's actually kind of like more of a struggle to turn. This feels pretty good for ice. It actually kind of reminds me of like the Mario Party. I don't know if it was Mario Party or one of the N64 games where you're on ice, and you gotta like kind of walk on those balls and knock each other out of like the ring. This actually feels a lot like that. So yeah, these are pretty good settings. I actually like how this works. And then if we were to go off of the ice, just let yourself slide off. Now you're back to normal settings. So that's all working really good. Let's try the snow. So snow doesn't seem to be really changing too much. Neither does grass. Let me see what we have our speed set to there. Okay, so I see where we messed up. We accidentally set friction factor twice, or I did. You guys may have set it up correctly during your first run. So let's just do set max walk speed. Let's do some live debugging. Okay, so just hook that up like that. And then now we should see the correct stuff. Let's try that out. So this is all working, speed's good. We'll go on to ice. Yep, ice is still working. And let's go right into the snow. Yep, now you're kind of like trudging through the snow slower. That looks pretty good. Then we'll go onto the grass. Should be more normal. Still a little slower, we have it, than when you're on the normal surface. So that feels pretty good. Snow is slow, and then ice is fast. Yep, so that's how you do it, basically. That's how you switch different surface types and have different movement attached to that. Something we can do in a future video is, instead of just doing our like capsule collision trace, we can do traces on the footsteps individually and add different footprints and different effects based on the materials. So that could be fun to do in the next one. I also want to use this as a foundation for like a more detailed ice material tutorial where we'll do scratching on surfaces. I did a short video a while back that kind of showed how you can use render targets to achieve that. And that setup's pretty in-depth, so that'll be kind of a unique one-off video from this, but I think the next one will probably do the footprints and different effects for the steps. So that's going to do it for this video. If you enjoyed it, please leave a like and subscribe. It'll help my channel grow. If you have any suggestions for different tutorials or things you want to see down the line, definitely leave them in the comments down below. And if you need any help with this setup, just message me on Discord. We have a little community kind of building there, and definitely it's a good place to post any questions, or also if you just want to show off your work and talk about what you're doing, I'd love to see it. So thank you so much for watching, and I'll see you in the next one.